Okay, so this is a basic introduction into vector components. So starting into more of the concept-based thing up here, you know the basic trig functions of SOHCAHTOA, sine, cosine, and tangent, but we're not really going to use tangent because we're focusing more on when you have the hypotenuse quantity. So we're just going to kind of ignore that. So breaking SOHCAHTOA, or breaking the SO in the part of SOHCAHTOA into its components, the sine of theta equals opposite over hypotenuse. So in reference to theta here, that's opposite over hypotenuse. And then the cosine of theta, theta is the angle, is the adjacent over the hypotenuse. And the reason you're using these two and not tangent is because you are generally going to be given the hypotenuse value, and we're going to be breaking it into its components. So that's why you're using these two and not tangent. So using basic algebra, we're going to substitute the values from this triangle into here. So the opposite for this is v sub y, and then the hypotenuse is v. These are just the values in the diagram. And then the adjacent is v sub x, so the x quantity, and then the y quantity, like on your average coordinate plane. So the adjacent is v sub x, and then the hypotenuse again is just v. And then just moving these around a bit, you end up with v sine of theta equals vy, v sub y, and then v cosine theta equals v sub x. And this is how you're going to break stuff into its components and find their values. So the first sample problem is when you have a vector going this way in the positive direction. We're assuming that like right or east is positive. So the value of this vector is 15 meters, and its angle is 28 degrees. And so I've broken it into a diagram of its components here, so a sub x and a sub y, the x and y aspects of it. And we're just going to plug stuff in over here. So this, looking up over here, we can see that you take the value of this vector and plug it in. It's going to be 15, and then you also plug in the angle, so 28 degrees. You also, I should mention, you also plug in the angle in reference to the horizontal point, so the x value, like north of the horizontal in this case, that would be classified as. And so you plug that into your calculator to get a value of 7.0 meters. So that's the value of the y component, or the length that this vector would be in reference to the length of the hypotenuse. Pythagorean theorem also applies here, but we're using trigonometry, which is more applicable to more situations. And then so for a sub x, or this x component down here, you're going to be using this bit over here with the cosine. So you're going to plug in the value of v again, so a in this case, so 15 meters. And then you're also going to plug in the angle again, so 28. And that is going to yield 13.2 meters. So that's broken into its components here. There's your answer. And then this is going in the opposite direction, so it's going in the negative direction for its hypotenuse, or west. What you can classify it as positive or negative up to your discretion, but I'm going to classify going left as negative. So that means that my x component down here is also going to be a negative value, but my y, since it's going north, is going to be a positive value. And I have 124 degrees, kind of like, if you say that this is your horizontal, so I want to find the theta right here. And so I just subtract 124 from 180 to get 56 degrees. And I need that so I can plug that into my equations here. So once again, referencing the equations from up here, c sub y, or this aspect of it, is going to be the value of c, so 18 meters, as we can see up here, times the angle, 56, which is going to give me 14.9 meters. And that's going to be the length of my y component of this. And then once again, I'm going to take the v, or in this case the c value, 18 meters, and again the angle, 56 degrees, plug that in, all to get negative 10.1 meters. And again, that's negative because you're going left, which is negative in terms of most physics diagrams.